Chase Edgar.
Hello everyone. Let's talk about the video we just saw of the wave at the baseball game. We want to look at what is the functional relationship between the number of people that participate in the wave and the time. So I've put some points in a table of how many people may have participated in the wave after a certain length of time. I didn't go to the game and count this or anything, but this seemed to make sense. So what I figured was after 1 second, 100 people had done the wave. It was a little bit slow to catch on, so after 2 seconds, 150 people had done the wave. After 3 seconds, 300 people. Then it started to catch on even more. After 4 seconds, 550 people. After 5 seconds, 850 people, and then it tapered off, and after 6 seconds, 1,000 people had participated in the wave. So what I did was I graphed this on a graph. I had time on the x-axis, and I had number of people on the y-axis. So you can just take a minute to pause your video and go ahead and plot these points on the graph. We have after 1 second, 100 people. After 2 seconds, 150 people. After 3 seconds, 300 people, and so on. So just graph these points, but don't draw any line through the points yet. I'll explain that in just a minute. So now that you've plotted your points on the graph, let's talk a little bit about the graph. What do you think the points on the graph represent? Well, we can see from the table that what we're doing is looking at the number of people who have done the wave as time passes. And if we look at both the table and the graph, we can see that there's a trend on the table and the graph that as the x value increases, the y value is also increasing. So as we move from left to right, we're also moving up. So what that means in our situation is that as time goes by, more people are doing the wave. Okay, so the trend is that as the x value increases, the y value also increases. And if we put this in terms of our real life situation, as time increases, the number of people who have done the wave also increases. Now, if we look at the graph from the other direction, if we start on the right and go to the left, we can see that as x is decreasing, y is also decreasing. So in our verbal situation, this would mean that as time decreases, the number of people would also decrease. And make sure in 3 and 4 that you're changing the wording around. Cross out number of people and put time. Cross out time and put number of people. Again, in number 4, cross out number of people, put time. Cross out time, put number of people. Because it just seems to make more sense to ask the question that way. So we want to look at what's our dependent and independent variable. Well, we can see that the number of people who do the wave depends on the amount of time that has passed. So that would make the dependent variable the number of people and the independent variable the time. Okay, so now what we want to try and do is we want to try to draw a line through those points that kind of goes through the middle of the points or kind of hits the most points possible. So this is the line that I've drawn here. This is called a line of best fit. And now once we've drawn that line, we want to look at the domain and the range. So we can see that the domain of this graph, that would be the x values, the lowest x value on the graph is about 1. And then as we move from left to right, we can see that the highest value is about 6. So our domain goes from 1 to 6. Now let's look at our range. So if we look at our range on the graph, remember range is y values, so we want to move from bottom to top. So it starts at 0 and then goes up to about 1,000 people. So our range goes from 0 to 1,000. We say that this graph has a positive correlation because the variables are changing in the same way. As time increases, the number of people also increases. As we move from left to right on the graph, we are going in the upward direction. So this is called a positive correlation. Let's try to make a prediction from the graph. Okay. We don't have any data for how many people have done the wave after 3.5 seconds. So let's try to make a prediction. So here's 3.5 seconds on the x-axis. Let's try to figure out how many people have done the wave after 3.5 seconds. So here's our line of best fit. And if we move over to the y-axis, we can see that about 500 people have done the wave after 3.5 seconds. So that's one possible prediction that could be made from the graph. After 3.5 seconds, 500 people have done the wave. Okay, 5th period, here's your chance to get famous on YouTube. Remember the survey that we took in class? We did a survey on the month that people were born in and the number of siblings that they had. So what I've done is I've recorded some of the results in the table, and then I've graphed a bunch of the points on my graph. So the question was, what month are you born in? And I put the month number, and then how many siblings do you have? And we want to see if there's a relationship between your birth month and the number of siblings that you have. So from the data I got, there was one person born in January that has one sibling. There was someone born in February that has one sibling. Also, someone born in January had 3 siblings. Another one had 4 siblings. Someone born in March had 2 siblings. Someone born in April had 2 siblings. A student born in June had 3 siblings. One born in August had 1 sibling. And one born in September had 2 siblings. So go ahead and pause the video and get all of that information down onto your table and your graph, and then you can continue as we answer the questions. So the points on our graph are going to represent the relationship between someone's birth month and the number of siblings that they have. We want to look at these points and see if there is a trend. For example, in the last graph, we found that as x was increasing, y was also increasing. However, if we look here, as x increases, we see both higher values and lower values as x increases. So there really doesn't seem to be any kind of a trend. So how about as the number of your birth month increased, what happened to the number of siblings you had? Again, we can see that sometimes as the birth months increased, there were more siblings, but sometimes there were fewer siblings. So really the results varied, or the results were different. Is there a dependent or independent variable in this situation? Well, in order to have an independent and a dependent variable, the value of one has to depend on the value of the other. So can we say that the number of siblings depends on the birth month? No, not really, because for the birth month January, we have 3 different numbers of siblings. For the number of siblings 2, we have 1, 2, 3 different birth months. So neither variable depends on the other one. They really don't seem to have a relationship. So since there's no relationship between the variables, they really don't have an effect one on the other. We're going to say there's no correlation in this graph. So let's see if we can make any kind of prediction at all from the graph. I'm noticing that we don't have any data for a birth month of May for month number 5. So I'm going to try to make a prediction about how many siblings someone would have that is born in May. So I look and I say, okay, well, maybe it should be greater than the number of siblings in April. Or, well, maybe it should be less than the number of siblings of someone born in August. This just isn't making any sense. I really cannot make any predictions from this graph. So we're going to say no predictions can be made. Okay, 5th period, thank you for your help with that very scientific survey that we did. All right, so let's go over and just get some quick notes here. So a graph that has a positive correlation is going to look like something like this. We may have points scattered all over the graph, but when we draw a line of best fit, we can see that generally as the x value is increasing, so is the y value. So let's think of an example of a situation that might have a positive correlation. Let's say that you are paid money by your parents for the number of hours that you work around the house. So the more hours you work around the house, the more money you get. So the hours and the money are both increasing at the same time. So we could say that an example of a positive correlation would be the relationship between the hours worked and the amount paid. Okay, negative correlation is when we have a scatter plot and we draw our line of best fit, and we can say that in general, as x increases, y decreases. So the variables are doing opposite things. For example, if I have 10 pieces of candy and I'm going to give candy to all of my friends that come into the room, the more friends that come into the room, the less candy I will have. So as the friends are increasing, my amount of candy is decreasing. So an example of negative correlation would be the relationship between the amount of candy and the number of friends. Okay? A graph with no correlation just has points scattered all over the graph, so that it's really impossible to draw any kind of a line of best fit. I mean, I could draw lines going this direction, I could draw lines going this direction. There's not really one line that is a best fit for all of the points. So this is a no correlation graph. And an example of no correlation was our example where we had the relationship between the birth month and number of siblings. There was no relationship between those whatsoever. Okay, so let's just look at a few examples down at the bottom. So what would be the correlation between the number of empty seats in a classroom and the number of students seated in the class? And I've kind of made a table over here so we can see the relationship. At the beginning of class, so this is my empty seats, this is my number of students. So at the beginning of class, before anyone walks in, I have 30 empty seats and I have 0 students. So maybe 5 minutes before the bell rings, I have 25 empty seats and I have 5 students in the classroom. And then after another couple of minutes, I have 20 empty seats and I have 10 students in the classroom. And as time, as it gets closer and closer to the bell ringing, I have more empty seats, but I have fewer empty seats, but I have more students. So as the empty seats are decreasing, the number of students is increasing. So I could say that this has a negative correlation because the variables are moving in opposite directions. Example 2 is the number of pets a person owns and the number of books they read in a year. So we could go out and do a survey of the number of pets people own related to the number of books that they would read in a year. And I think we could pretty safely say that we would find no relationship between those two things. So there is no correlation. Number 3, the number of iPhones sold and the cost of the iPhone. So here's the iPhones sold, and here's the cost of the iPhone. Now, usually when an iPhone comes out, it's very expensive. So a new iPhone might be, let's say, $700. And the number bought at the beginning is going to be very low. Maybe on the first day, there are 50 iPhones sold. But then a few months after it comes out, there's been maybe 200 iPhones sold, but then the cost goes down to $600. And then after a year, there may have been 1,000 iPhones sold, and after a year, the cost is all the way down to $400 because there's a newer model that's getting ready to come out. So we can see that the number of iPhones sold and the cost of the iPhone are moving in opposite directions. The number of iPhones sold is increasing while the cost is decreasing. So this would again be a negative correlation. And lastly, number 4, the number of members in a family and the size of the family's grocery bill. So what happens to your grocery bill the more people you have living in your house? Well, the more people that are in the house, the more money you would spend on groceries. So as the grocery bill is increasing, as the number of members of the family is increasing, so is the grocery bill. So they're both moving in the same direction. This would be a positive correlation.